So coming to this Oracle databases, we have a cluster kind of database architectures. I hope you're aware that cluster environments.
Sorry, come again. Please repeat your question.
Yeah. So in Oracle database, we have a separate concept called cluster. Like so, cluster in the sense that there will be two servers which will access the same database, and the database will be in the shared storage. It means two servers will access the same storage. So, do we have any kind of that provision here in GCP?
You mean to say shared drive?
Shared
drive.
drive.
It's the same storage where the data is kept. Both the servers are connecting to the same drive, which means if one server writes anything to the drive, the other server will be able to see it. So it's shared drive concept.
Exactly. Yeah.
Which typically happens in all the databases.
Yes. Yes.
So you have that concept. I would say the database services are designed in the same manner.
No, I am not aware about in the cloud environments. That's why I'm asking.
Yeah, it is there. In all the clouds, the service is there.
Okay.
You say you have both the services. I'm saying you can use a shared drive as a network drive.
In on-premise, what we will do is we will create two servers. So for the shared storage means we will procure any NAS or any SAN storage. So what OS team will do is they will attach the SAN storage to both servers. Yeah,
I got your point.
Yeah.
So
Okay,
see, you have multiple options when it comes to shared storage. Okay, so when it comes to shared storage part, there are multiple options which is available in cloud. Let's first talk about those options. So we have options. For example, first we have a network drive. Network attached storage, you can say.
Okay.
Right? Network attached storage. Now for that, you have file share service. You have EFS service, Elastic File System. These are the services which are available. Okay. In fact, you have an enterprise service, which is very, I would not say expensive, but which is very efficient, which is known as NetApp Files. NetApp Files is one service, is a third party that provides you NetApp files, and these files support both SMB, NFS, and dual protocol. Okay. So what is SMB NFS, which basically means that you can use NetApp files to remotely attach high performant drive on your servers, and your servers could be Linux based, could be Windows based, or it could be a combination of which. For example, some applications, middleware applications like Informatica, they support both Linux and Windows based application environment. So from there, you can use this NetApp files also. This is what I have actually seen being used in most of the enterprises. In fact, I support a couple of customers who use Azure NetApp files or NetApp files with cloud. So that's the another option that you can do, right? Then there is one more option, which is known as, which is specific to Windows only, which is storage space direct, which is known as SSD. And this is available in Windows 2016 and above OS. Now, what is the storage space direct? In this case, you will not have one shared drive. You will have two servers. They have their own drives attached to them. However, storage space direct will create a virtual endpoint, which basically means any delta that changes to one server automatically gets replicated to other, and it's a synchronous replication. Something which happens in databases, synchronous and asynchronous replication. So any data that you write in one server, it automatically gets copied over to the other server drive. That's storage space direct. So that is also one of the option for sharing storage.
Okay, got it.
Right. So these are the options. Then you have third-party solutions also using which you can enable the functionality. In fact, your SUSE Enterprise Linux also supports it. We call it SUSE SUSE is one Linux version which is primarily used for most of the companies. Why? Because this supports most of the capabilities. It is not as expensive as Red Hat Linux is, and SUSE is certified to work with SAP. And SAP is one of the most widely used ERP solution across the world. So most of the companies which are using SAP or which use SAP as their ERP module, they use SUSE Enterprise Linux. So its adoption is very high in corporate environment. Now this SUSE Enterprise Linux also have similar facility wherein you can configure shared storage.
Okay.
So this is also one of the options which you have when it comes to shared storage. So these are the options basically which are available shared storage. Hope that answers your question. Now Google supports integration with Google supports network attached shared storage. Google supports integration with data files also. If you provision a Windows-based machine in Google, you can directly configure it at the OS level. And if you provision a Windows Linux-based machine, SUSE, then you can also configure it at OS level. So this is OS level configuration. These are enterprise solutions. You can go for one of the options based on your application requirement and also the budget, because NetApp files is a bit expensive option, but this is one solution which most of the organization uses because its performance is very higher.
Okay.
Let's go back. So we have completed we have basically completed the cloud storage part. This is your file store. This is the answer to your question in Google. So in Google, you can use a file store, which is a network attached storage, which is good for latency sensitive workloads. However, it's a NAS option. It's not a persistent disk. It is like both the systems will use the same file store. Whatever data needs to be kept, it will be kept in the file store. That's how it is. But file store is a network attached storage, which means it is not directly mounted on the system. You need to create a manual mount process. That's what you can do, right? Now, some of these solutions we will discuss, but not today. I have received a request from your management to inform them when I'm discussing these solutions so that they can involve some additional team members from other projects from where this request has come. So we will skip to storage and database services. We'll move to compute services. Once we are done with compute, we'll look into the logging, monitoring and auditing part. Once we are done with logging, monitoring and auditing, then we'll talk about some specialized services, advanced services. And at that point in time, you will have additional participants coming from other business units also. Is that okay with everyone?
Yeah, yes, that's fine. Because actually I am from the database team. That's why I asked this question. Yeah, I got your
that's
point.
Okay. But we have some other. I've got an email from your management, Raj Shekhar.
Understood.
I believe he's one of the program managers in Nexter, wherein they have requested some additional modules to be covered. So I will also and inform them when it is covered. So I have actually informed them that I will let them know when it gets started. Right now, the focus is on core services.
Okay.
All right, so I'll just close this. We'll move on to the next service, which is compute service. Okay, so when it comes to the compute service in Google Cloud, you have many compute services. If you specifically want to know, we have the most popular compute service you already know, which is Google Compute Engine. This is the most popular compute service in Google Cloud or in all the clouds, basically, which is known as virtual machine. Then you have App Engine. App Engine is another compute service that you can use to deploy applications in Google Cloud without worrying about the application, without worrying about the underlying infrastructure, which is your PaaS service actually. that App Engine, which is another type of compute service. You can compare App Engine with Elastic Beanstalk or Azure App Service. Then the third compute service you have is Google Kubernetes Engine. You have Cloud Run, you have Google Functions. These are the compute services in Google Cloud that we have. Now we are going to focus on this service, virtual machine. I'll also talk about other services, but as I said, when the right time comes, I'll talk about it when the other team members also joins. So right now our focus is on compute service, which is one of the core services in Google Cloud. So let's talk about it. So let's look at virtual machines. Okay, now when it comes to virtual machines, we'll talk about compute engine. And when we look at compute engine, these are the options which are available. These are my compute services which are available. Now look at this slide carefully, and then we'll talk about it. So what you see on the screen are the compute services in Google Cloud. They are all the compute services as we speak. If tomorrow they adds more, I can't say, but this is the current situation for today. These are the compute services in Google Cloud. So you will see all the compute services and you will see the use cases also. For example, let's start with language support. Now, when it comes to compute engine, it's virtual machine. You can deploy operating system in multiple languages here, and it supports all the languages. GKE also supports all the languages. However, App Engine supports these programming platforms: Python, Node.js, Go, Java, Ruby, PHP. Similarly, App Engine basically have two varieties, two SKUs, standard and flexible. It's like basic and standard. So in this App Engine, you support these languages. Cloud Functions support these languages. Cloud Run supports any language. Then comes the usage model. Model basically means which service delivery model of cloud computing this service falls in. So Compute Engine falls in infrastructure as a service, wherein you manage the infrastructure end to end. So all backup, maintenance, update, patching, antivirus, all that you will manage. GKE is both IaaS and PaaS because GKE is a managed Kubernetes service in which Google manages the master node control plane and you manages the node, which is your actual cluster where all the nodes and pods and your containers are running. So it's both IaaS and PaaS service. App Engine is a PaaS service, full, pure play PaaS service. Cloud Function is primarily meant for microservices architecture. So if you have applications configured with microservices design pattern, then you can use Cloud Functions for it. And Cloud Run is also a PaaS environment. When I say PaaS, it means that you bother about your application and data and let the infrastructure be managed by Google Cloud. So Google takes all the pain of management and administration. Does it support scaling? Yes, Compute Engine supports server auto scaling. You can auto scale, scale up and scale down in real time based on certain thresholds. GKE is cluster based application. So you basically create a cluster of nodes and those nodes are containing pods. Pods are running containers. Containers are hosting applications. So it's a cluster based. App Engine, both App Engine supports auto scaling. Cloud Function is serverless and Cloud Run is serverless. Can one of you tell me what do you understand by serverless? What is your understanding of serverless? Any one of you?
So you will be using compute, resources, but without having any physical machine or virtual
Okay.
machine.
And then how does it use resources then if there is no virtual machine? And where exactly do you store your application binaries then?
Sorry, application?
Right. I'm saying, imagine if it's a server based, you will provision a VM with certain configurations like CPU core, RAM, storage. You will log into the VM, deploy the application. You can deploy it on C drive, D drive, right? And whenever that application runs, the the virtual machine infrastructure is leveraged. I'm the CPU and memory, whatever is allocated is basically being leveraged or consumed from. This is a server based. Now we are saying serverless, and you're saying that it doesn't involve virtual machine. Then where exactly are you storing your application?
Server and serverless are both are having the hardware on the background. Both are having server, but coming to the serverless means it does not have any boundaries. Like it does not have any kind of a boundary for RAM, CPU, storage. So we can able to extend. It cannot. Maybe it can automatically extend.
But that's auto scaling. You can do that using auto scaling also.
Okay.
All right. In a layman terminology, if you want to explain serverless to somebody, this is how you can put it. So serverless basically means that your application, your code, dependencies, user space, all of that is stored into a storage. It is not allocated to any hardware. So no hardware is allocated. Hardware is allocated to your application when there is an event or action that happens. So whenever there is an event which is triggered, let's say you have an e-commerce application, it is running in serverless mode. So your application is stored on a storage. Now, whenever a user types www.amazon.com, let's say it's Amazon, the moment that user request comes to the load balancer or a WAF or a firewall, which is configured with your application code, it will quickly allocate server to the application so that it can serve that request. And as long as user continues to remain on the website, keeps moving from here and there, that resources will continue to remain allocated. The moment user is down, user is gone, user disconnects the session, the resources are taken back, resources are released. So in this approach, you save a lot of money because you do not have permanent resources allocated to your application, which was the server based example, wherein you deploy an application or a server. Now, whether that application is consumed, whether it is used or not, you are still paying for the resources. Google will charge you every month for the server cost, storage cost, networking cost, IP addresses cost, and whatnot. But in case of serverless, it is not the same arrangement. Why? Because you don't have any hardware resource allocated in real time or permanently. So that's what serverless is. Now, does it mean that I can use serverless to host SAP HANA? No, forget about it. It won't be possible. It's an in-memory database. It requires resources all the time. So any application that is microservices based, which has smaller modules that does not require much infrastructure, they are a perfect use case for serverless. And that's exactly what you see there, Cloud Functions and Cloud Run. They're for microservices based architecture. Now, Cloud Run can also support containers. So you can deploy containers. You can deploy containerized applications in Cloud Run. And that is how Cloud Run is different from GKE. In GKE, it is server-based infrastructure. And in Cloud Run, it is serverless infrastructure. But in both applications, you can run your containers. So this is your use case basically. So you can see GKE, we use it for containers. Cloud Run, we also use for deploying and scaling containerized applications. And Compute Engine, we can use for general workloads. I'm saying for anything and everything. App Engine, we can use for scalable web applications or mobile backends. But you can also use Compute Engine for web applications. The difference between Compute Engine and App Engine is that Compute Engine, you manage the infrastructure. App Engine, Google manages it on your behalf. So let's just assume that Google is putting its IT team to manage your infrastructure, and that's why App Engine is a bit expensive than Compute Engine. So these are my options. Cloud Functions is lightweight event actions. If you have an event-driven application, you can use Cloud Functions for it. So these are my compute services. Any question on this, guys? Let's move on in that case. So our focus is on Compute Engine for today. So when it comes to Compute Engine is part of Infrastructure as a Service delivery model, IaaS. It supports both predefined and custom machine types. Predefined basically means you have a couple of predefined sizes available that you can pick and choose from, or you can also create your custom size. Now, this capability is not available in Azure and AWS. In Azure and AWS, virtual machine sizes are predefined. Whatever is available, pick and choose. You can't customize it, but Google gives you the capability to customize the size also. Now, what does the virtual machine contain? CPU and memory. It contains storage. These are the components of virtual machines. So it requires processing and memory. It requires storage. Now, storage could be local SSD. It could be cloud storage. It could be zone or regional persistent disk also. So we typically go with persistent disk. We can also use local SSD. Local SSD basically means an SSD which is directly attached to the hypervisor. So zonal or regional persistent disk is the option that 99% of the customers would use with Compute Engine or virtual machine. Cloud storage basically means that you can also have your virtual machine communicate with cloud storage bucket to read or write data to it. Virtual machine has networking components, which means it is configured inside a VPC, inside a subnet. As part of its placement in the subnet, it gets a private IP address, which is allocated by the DHCP service, which is configured at the subnet level. And it also gets a public IP address, which is ephemeral IP when you provision the VM. While you provision the VM, you can select whether your VM needs a public IP or not. So that's your networking component. Then comes Linux, the operating system component. Your virtual machine can run both Linux and Windows. You don't have Mac OS available in Google Cloud. However, you can build a custom image. You can bring a custom image, and you can also deploy Mac also. You can also deploy Google. So Google Chrome OS, they are planning to make it available, and it is available in some regions also. We need to check whether it is available for our account or not. So you also have that option available for operating system. So this is about my Compute Engine. Any question on this? OK, let's move on. So on this slide, you basically see the features of Compute Engine. All right, let's talk about it. So when it comes to Compute Engine features, you get machine right sizing, which means as part of the Compute Engine service, you also get right sizing recommendations. Based on the utilization of a machine, Google provides you recommendations whether you should upgrade the virtual machine or downsize the virtual machine, whether it is under provisioned and overutilized or over provisioned and underutilized. You get that recommendation. You get the monitoring statistics. Some basic monitoring data is also available, and recommendations basically comes every 24 hours after the virtual machine is created. You also get instance metadata, which is some basic information. You also have startup or shutdown scripts available from Google Cloud. When it comes to the policies, you have live migrate autos restart policies available. It supports load balancing also. So you can use load balancers to load balance the traffic coming to your virtual machines. It supports patch management. You don't need to purchase a separate third-party solution to manage patching for your virtual machines. You can configure patching options right from the console, and and you can manage the entire patching lifecycle from the console itself. It supports per second billing. So if you run a virtual machine for 10 hours, 20 minutes and 15 seconds, you pay accordingly. It supports sustained use discounts, which means depending on your commitment to run virtual machines in Google Cloud environment, you will get discounts. This is similar to reservation that you have in other clouds. And it's preemptible and spot VMs. Preemptible and spot VMs basically means any virtual machine, or let's take this example. Let's say Google has a data center. Google has opened a new region. Let's say Google has opened a region in southern part of India, which is Chennai. Obviously, from day one, Google will not have the entire capacity blocked. Slowly and gradually, Google will have customers provisioning resources in Chennai region, one after another. Google will also do a lot of marketing to kind of attract more customers, but it will take time. However, when Google builds a region, it will need to build data center in that region with a minimum number of servers, and that minimum will be more than 1,000, 2,000 servers. Give me a moment. So that minimum, so Google will build a data center, but the data center resources are not getting occupied from day one. And to get returns on their investments, what Google will do, or what all service providers does, they basically offer extra discounts on their hardware in the form of spot VMs, which basically means if you have any immediate business requirement, let's say you want to do some proof of concept, you want to test some capabilities in cloud, you don't need it permanently, but for a temporary period, then you can go for spot VMs. You can request, you can check if spot capacity is available in your region. If it is available, you can request for it. They'll give you those VMs for 24 hours, 72 hours, or depending on the duration. You will be able to use that VM. After that duration is over, Google will take it back from you. Google will, discard the infrastructure and you will pay accordingly. And in this arrangement, you can get up to 90% discount, which means a VM that cost you $100 a month, you will get it for $9, $10. That's the benefit. So you cannot use it for production environment, but for temporary initiatives, proof of concepts, any testing, R&D you want to do, check if you have spot or preemptible VMs available. And if yes, go for it. Now there is no SLA for it. Why? Because it's a temporary arrangement. So Google will not give you any SLA. Sometimes what happens, you take a spot VM for 24 hours and within couple of hours, you lose access to it. You connect with Google and say, hey, what happened to my VM? Google says, sir, there is no SLA. However, let us check. And when they check, they come back to you and say, sir, we had a customer requesting for capacity, so we had to give that capacity to the customer. OK, so there is no SLA available, and but it doesn't mean that they can take it anytime. No. It only happens once in a while when spot is taken all of a sudden. Otherwise, you get spot capacity, spot VM's capacity as per the commitment. I'm saying when you request for spot, they will give you an option to select the hours. You will get it for those many hours. They will not take it back unnecessarily. All right. So this was about compute engine features. Any questions do you have on this, guys?
Yes, sir. We can.
Okay, let's move on. Then comes the compute. As I said, you get multiple machine types. So you get several machine types, and you can get network throughput up to 2 Gbps per vCPU, small exceptions, theoretical max of 200 Gbps with 176 virtual CPUs. Now remember one thing, guys, cloud is all about virtualization. There is nothing physical that you get in cloud. You get a virtualized version of that service. So it's a virtual CPU, which is equivalent to one hardware hyperthread. Or you can say two virtual CPUs are equal to one physical CPU. That's how it happens in cloud environment. Next is storage. Now, storage comes in different options. You have standard storage, you have local storage. Standard storage basically means persistent disk which are attached to the VM. SSD, you already know what it is. It is solid state drive. It is a high performing storage service which is based on SSDs. And prior to SSD, we had magnetic disk, which is known as standard storage. Local SSD basically means a storage that is directly attached to the hypervisor. Standard and SSD PDs scale in performance for each GB of space allocated. So the performance of these disk depends on the each GB of space allocated. So example, if you attach 100 GB of disk, you will get a different performance. When you attach 10 GB or 1000 GB, you will get different performance. So the more space you allocate on the disk, the more performance you get. That's how Google put it. Resize disk or migrate instances with no downtime. Now in Google Cloud, you can change the size of the disk in real time. Something that is not allowed in Azure and AWS. You will need to shut down the VM. Only then you can resize the disk. But here you can resize the disk and you can change the performance. I'm saying standard SSD with no downtime. That's what Google allows. Networking. When it comes to networking, it provides you robust networking features. You have auto custom mode networks, which we have already talked about. We have inbound, outbound firewall rules, which are based on IP addresses, and they can also be based on instance and group tags. So we have seen both IP based and tag based rules. It is regional. It also supports regional HTTPS load balancing, network load balancing, and global and multi-region subnets. Your networking, I'm saying the subnets that you create, they are global and multi-region. Your VPC is global and subnets are multi-region. You can create multiple subnets in multiple regions. So these are the components. Then comes access. How do you access your virtual machine? For Linux, we use SSH. We can use SSH from Google Cloud Console, Cloud Shell, or we can also use Cloud SDK. We can also use SSH from third-party clients like PuTTY with SCP. For SSH, we need a firewall rule to allow traffic on port 22. We can also do Windows. If it is Windows, we can do RDP, which involves RDP clients. It uses a PowerShell terminal, which requires setting the Windows password. And you can enable the rule, which is 3389. That's what Windows is. So two methods. You don't have Mac here because they don't support Mac. Let's understand the VM lifecycle. I want you to give it 2 minutes. Read this lifecycle carefully, then I will explain it to you. Okay, let's talk about it. So VM lifecycle. Now VM lifecycle starts with provisioning. It starts with service provisioning. At the time of provisioning the VM, you basically select the CPU and memory, the root disk type, whether you need standard SSD, whatnot, and any additional disk that you need. That's what you do. After you select all of the configuration, you submit the configuration. That's where the VM goes into staging mode. In the staging mode, the VM is configured as per the given configuration. VM gets an IP address, internal, external, based on the configuration. VM image, when you are provisioning the VM, you select the image, whether it's Windows, Linux. That image is stored in the cloud storage. The image comes, the IP address comes, and the VM is provisioned, and the VM boots. When the VM boots, it comes into running stage. Now, when the VM runs, you can also run a startup script on the VM. You can access the VM using SSH or RDP. You can modify the use of the VM. I'm saying you can change the configuration of the VM, all that. So startup script, you can set get metadata. You can access image. You can perform snapshots. You can move VM to a different zone also, different availability zone, which is live migration. So that's what you do. Now, once that VM is running, there's an option to restart the VM also. So you can restart the VM or shut down the VM. So if you restart the VM, it will come back to the provisioning and then staging. But it's just that when you restart it, you doesn't give all the capabilities. It picks up the same configuration all the time. Then comes the stopping the VM. So when you stop the VM, you can also run shutdown scripts. You have both startup and shutdown scripts that you can run. Using the scripts, you can configure automation, which means, let's say at 10 o'clock in the morning, the VM will get automatically started. And at sharp 6 in the evening, it will get shut down. It will automatically shut down, stop. And then you terminate the VM. Terminate means deleting the VM. Deleting the VM basically means releasing all the resources that you are acquiring on the VM. And the moment you terminate it, your billing will stop on the VM. Then and there. That's what termination is all about. So that's the VM lifecycle that you need to be aware of. Now, why do we focus on theory? We focus on theory because if we directly get into the provisioning, or if you directly learn how to provision a service, don't focus on theory. You will not always be aware of all the capability that are possible, that it provides. That is why we look at theoretical aspects so that we understand the capabilities which are available. Okay, then changing VM state from running. So it basically shows you that you have multiple methods through which you can perform the VM reboot, restart, and all those capabilities, which is very much available with the virtual machines. Okay, then availability policy. You have some availability policies in the VM wherein you can configure automatic restart, host management, live migration. We'll discuss that. Patch management. As I said, you can also manage the patching of your virtual machine from Google Cloud Console itself. You don't need a third-party solution like WSOS, SCCM, or BigFix. You don't need those solutions. You can directly manage it from the portal itself. You can keep your infrastructure up to date. You can reduce the risk of security vulnerabilities. And this patch management also includes compliance reporting and patch deployment. So you can configure the schedule. As per the schedule, the patches will be pushed on the VMs without interrupting your business operations. So these are the tasks that you can perform with the patch management module. You can create patch approvals, set up flexible scheduling, apply advanced patch configuration settings, manage these patches job or updates from a centralized location. So it's a pure play, patch management solution that Google offers as part of its compute engine offering. Now, billing is very important. When you learn cloud, learn two things: security and cost. That is what cloud is all about. So when it comes to the cost, if you stop a virtual machine, it will only stop the memory and CPU cost, CPU and memory cost. The attached disk will continue to get built. Any IP address that you have reserved will continue to get built. So remember this part. This will only get, I'm saying, if you want to stop billing for attached disk and reserved IP addresses, you will need to delete the virtual machine, terminate the virtual machine. What are the actions which are supported on a virtual machine? Terminated, basically they say that stop and termination is the same thing here. So you can change the machine type after the machine is stopped. You can change the machine type. I'm saying from one series to another, you can put it. You can migrate the VM to another network when it is stopped. You can add or remove attached disk, change auto delete settings. You can modify instance tag also. Tag using which you are configuring firewall rules. You can modify custom VM or project-wide metadata. You can remove or set a new static IP address. You can change the IP address. You can modify VM availability policies, which is automatic start, restart, and shutdown. However, you can't change the image of a stop VM. Now, this is not possible. Let's say your VM is running Windows operating system. You stop the VM and then convert it to Linux. That won't be possible. Why? Because they are two different operating systems. they follow different architectural aspects. So a VM cannot, an OS of the VM cannot be changed. So that is only thing which is not possible. Rest of these operations are possible. Now we will directly get into the lab. We'll provision a VM and see for ourselves how it works, how options are available and how it works. Then we will
one
move
question,
on.
by the way.
Yeah.
One question. See, I saw that like initially when we talked about the compute, right? There was something like I saw that live migration or something, right? So what is that like live migration? Yeah.
Live migration means you can move your VM from one zone to another, one availability zone to another. That's live migration.
Okay. So while application is being run, right?
Yep. It will not impact the application. Why? Because availability zones, see, you can't do this activity in other clouds. Why? Because in other clouds, network is dependent on availability zone. Google uses a global network, right? So since it uses a global network, you can live migrate your VM from one zone to another. What it will do? It will just change the IP address of that VM. And then in the backend, it will move that VM. I'm saying for you, it is the IP address which is changing. Nothing will change. And in the backend, it will move that VM from one zone to another, from one data center to another. And it happens in real time. You don't even realize where it is happening.
Okay. So in that
It's
case,
like when you have an inverter at home, when there's a power cut, it automatically switches from DC to AC. Sorry, AC to DC. Do you realize? Yes, I'm saying it's a blink of an eye. You will realize that yes, now it has moved to DC. Why? Because the electronic appliances, they start to make noise when they when they get moved from AC to DC, alternate connect to direct connect. But in case of Google Cloud, it's a live migration. You don't even know that your VM has, I'm saying you will know, obviously you're migrating, but user will not have any impact. End user will not have any impact. Application will continue to run, no impact.
okay, got it. But underneath whatever we have a static IP, will be the same or it will be going to change?
It will be the same because IPs are tagged to a location. You're just migrating from one availability zone to another. You're not migrating across location. I'm saying you're not migrating a VM from India to US. You remain within India, and IP addresses are tagged to our geographical locations. So if I purchase an IP address in Delhi, I can use it in Bangalore also, or anywhere in India. Same is the case with other countries. Your IP address will not change. It will remain then and there.
Okay, thanks.
However, it has to be a static IP. If it's a dynamic IP, it will change. Okay, let's understand the options in the size and configurations. So when it comes to compute options, I'm saying what are my options to provision VMs? How do I create a VM? I can provision a VM from console. I can provision a VM from command line. I can also provision a VM from REST API using REST API options. All these three options are available. Now, when it comes to a virtual machine, we have three things, which is machine family, machine series, and machine type. See, when you're learning a technology for your personal consumption, you can skip the theory and you can directly see how the technology works. But when you are learning it for providing support, you need to understand the theoretical aspects, because in operations, you will get a lot of requests wherein your customer would request you to change the machine type or change the machine family or machine size or series from one series to another within the same family. So machine family, series, and type you need to understand. Now, when it comes to families, there are four types of families: general purpose, compute optimized, memory optimized, and accelerator optimized. We have fifth type, which is not here, which is confidential computing also. So general purpose basically means virtual machines that can be used for all the purposes, common sizes, typical sizes. Compute optimized basically means a virtual machine that is optimized for compute. I'm saying it will have more processing capabilities as compared to general purpose machine. It is optimized for processing request. Memory optimized basically means a virtual machine which has more memory to CPU ratio, and it has the capability to manage multiple read-write requests. That's what memory optimized. So any analytical application, processing application, data processing application, we use compute optimized. Any database is memory optimized because database contains data and all the time applications are reading or writing data to database. So a lot of memory transactions happens. So you can use memory optimized compute engine machines for databases. Then comes accelerator optimized, like graphics. Any machine, like gaming industry, mobile industry, OTT industry, live streaming industry, they use accelerator optimized virtual machines because they run quicker. Then comes machine family. So we talked about three things: family, series, and time. So if you want to see family, you can see here in general purpose, we have E2 series. Inside E2, we will have types. Types means configurations. We can use it for cost optimized workloads, day-to-day computing at lower cost. We can use it for web servicing, application services, back office, small, medium databases also. And you can run microservices, virtual desktop development environments. Then you have balanced, which has balanced ratio, N2D, scale out optimized TAU, D2D. These are all general purpose virtual machines. It shows you the use cases also. Similarly, we have compute optimized. You can see they are C2 series, ultra high performance for compute intensive workloads. And you can put media transcoding AI applications gaming here. Ultra high performance for compute intensive. M series is memory optimized. You can in fact run SAP HANA, which is in memory database here. So it says medium in memory databases such as SAP HANA, tasks that require intensive use of memory with higher memory to CPU ratio. That's memory optimized. Examples are N1 and M1, M2. Then you have accelerator optimized, when you need high performance compute, massive parallelized computations, and ML training and interface. So it is optimized for high performance computing workloads. And A2 series is there. Now the question is, what should you start with? You must always start with general purpose. And based on the monitoring data for a month, or let's say a minimum of 15 days, you can decide whether CPU utilization is more or memory utilization is more. If you find that there's more CPU utilization, then you can go for compute optimized. If you find that memory utilization is more, you can go to memory optimized. And accelerator optimized is specifically for data processing or I will say applications which processes a lot of data, like AI ML applications or applications that are running in a plant. For example, I support a customer who happens to be the second largest manufacturer of coatings as well as paint in the world after PPG, ExxonMobil. Now that customer has multiple plants, one in Sabli, Gujarat also. They have plants in China, Europe, and US. Those plant contains boilers. Boilers are large equipments in which paint is boiled. I'm saying paint is nothing but a chemical. That chemical is put to heat so that it boils, so that you can mix that paint easily. Now that boiler sends a lot of temperature data. The temperature has to be maintained in the boiler. If it is below the requirements, the paint will spoil. If it is more than the required temperature, degree Celsius, it may explode also. And if the boiler explodes, it will be a disaster at the site. So what they do, they use applications. An application which can measure the temperature of the boiler and the deviation in temperature on second basis, and it can take multiple readings on each second. Imagine the kind of processing it is doing. There are 3,600 seconds in 1 hour, and it is taking 100 readings every second. So it's like 300,000 readings it is taking every hour. So that is the type of processing it is doing. For those type of workloads, you need accelerator optimized machines so that there is no performance bottleneck. Is everyone with me on this? Okay, let's move on. Now let's see how do we create a virtual machine. So this is the option. As I said that you can create a custom virtual machine also, which means you're not going with compute memory or general purpose or accelerator optimized. You want the size of your choice. So when you provision the virtual machine in the machine type, you can select custom, and then you can drag this to the right, and you can select the CPU and memory. Now it cannot be possible that you say that I want with one CPU core, I want 200 GB of memory. No, you need to follow the system architecture also. Or it cannot be possible that you will use 1 GB memory and 5 CPU core. No, memory will always, for each CPU core, there has to be a minimum of 1 GB of memory. This is the standard architectural standard for computing systems. So you cannot violate the standard or manipulate it. And that is why cloud services do not allow this custom options. Azure AWS doesn't allow. They say that we have thousands of options available, pick and choose. We will not let you create your own because you are not aware of architectural aspects. Google does it, but you will not be able to do this. As I said, you cannot provision 20 CPU core with 10 GB of memory. Memory will always be higher than the CPU core. When you provision a virtual machine, you choose regions and zone. These are the places where Google has its regions available. You can pick and choose any of the region and the zone which are part of that region. When it comes to pricing, as I said, it follows per second billing with minimum of 1 minute. Now, if you run a virtual machine for 30 seconds only, you will get 1 minute of billing. You will get 1 minute of billing. However, if you run a machine for 1 hour, 20 minutes, 30 seconds, you will only be charged for 1 hour, 20 minutes and 30 seconds because minimum of 1 minute has to be there. Resource-based pricing also happens, which means each vCPU and each GB of memory is built separately. Discounts, you get sustained use discounts, committed use discounts, and preemptible and spot VM instances also. So that option is also available. As I said, based on your commitment, Google will give you certain additional discounts over and above pay-as-you-go pricing when you commit Google that yes, we can do it. Then recommendation engine. As I said, if your virtual machines are not utilized, you also get recommendations for underutilized virtual machines. And you get free usage limits also. So if so if you're using a trial, you can use free usage limits also on virtual machines. Okay. Then comes sustained use discounts. As I said, you get some additional discounts also. So it is like when you are provisioning a virtual machine and you deploy a production application on it. Obviously, you don't want to terminate that virtual machine on the fly or at random order. You would not want to shut down that virtual machine because it's a production application. So which means that you will have that machine up and running throughout the day, round the clock, 365 days a year. For those virtual machines, you can look for discounts like that. Okay, preemptible. So I told you that we have preemptible VMs also, which means lower price for interruptible service. It says interruptible service. As I said, Google can take it anytime. So it is interruptible service, but you have a lower price, 91% discount, up to 91% discount you get. VM may be terminated at any time. It doesn't usually happen. Take my words for it. I have been working with Google Cloud for a long time or with other clouds. They follow the commitment. If they have given you for 24 hours, 72 hours, they will not take it back. It will only happen in the worst case scenario when there is a customer who comes and says that I need this capacity. Then Google will take it. And this doesn't happen all the time. So it says no charge if terminated in the first minute. 24 hours is the maximum duration that you get it for, and 30 seconds terminate warning, but not guaranteed. It says, but not guaranteed. Sometimes you get a warning also that your resource is getting terminated, but not guaranteed. Time for a shutdown script. No live migrate, no auto restart. Since this is a temporary option, no live migrate, no auto restart. You can request that CPU quota for a region be split between regular and preemptive. So Google, on the other hand, similar to other cloud service providers, also have service quotas. Quotas basically means a specific capability or capacity that has been allocated to each customer. Whenever you reach that quota, you can always request a quota increase. You can always make a quota request increase and they will increase your quota without any challenge. Happily, they will do that. It means you are giving them more business. So preemptible VM count against CPU quota. Then comes spot VMs. Now, spot VMs is the latest version of preemptible. Now, the benefit of spot VMs are that they share the same pricing model. However, there is no minimum or maximum runtime. Here you have a 24 hours of runtime maximum. If you notice, 24 hours max. Here there is no minimum or maximum. When you create a spot VM, if it is available, then you can select the time frame. Google also shows you time frame for which it is available. Spot VMs are finite compute engine resources, so they might not always be available. No live migrate, no auto restart. Best practices use case help you get the most out of spot VMs. So you can use spot VMs. Once again, I'm telling you, do not even think of using this service for a production environment. You never know when it is taken back from you. Next. Sold tenant nodes physically isolated workspace. Now, the other thing, Google, unlike I'm saying similar to other cloud service providers, also provides you physical hardware in its data center. If you are one of the customer who doesn't want to run services on a shared infrastructure, you don't want other customers to have their resources running where your services are running, you can also request for hardware, dedicated hardware from Google Cloud, and you will only use your own machines in the Google Cloud. I'm saying on that your customers. So you can see here normal host. In normal host, you will have 3 customers, blue, yellow, and gray. You can see on a normal host, all the customers are using the virtual machines. So one customer has 1 virtual machine, other customer has 2 virtual machine, one customer has this virtual machine. But if you go for sole tenant host, which is dedicated hardware, only one customer is running all the virtual machines, which is customer 1. So it says you can bring your own license also. So for the sole tenant, you can use your own virtual machine OS license. You can also use your VMware or Hyper-V virtualization license here. So not many customers go for dedicated hardware in cloud, because if you need dedicated hardware, then you will not get value from cloud. Cloud is all about shared resources because it gives you cost benefits. If you do the dedicated, you would probably end up paying more than what you could have paid when you had the same infrastructure running on premises. So I don't see many customers using this capability. Shielded VMs, they offer variable integrity. It basically means that this is more secure virtual machine, which supports hardware level security. So these days, when you purchase a laptop from Intel, they come with TPM, Trusted Platform Module, or secure boot capability. So If you use shielded VMs, you get secure boot capability, you get virtual trusted platform module and integrity monitoring, which means if there is any change that happens to the VM boot sector or to the firmware of the VM, it will be reported. So these days, there are ransomware or viruses which are boot sector virus. They affect the boot sector of your machine and they take over the machine from boot sector. And if that happens, you have no solution in this world that can protect you, because any application that will protect you can only be made to run when the machine is up and running. But since it's a boot sector impact, it will not allow you to run any application. You will have no option but to pay or destroy that resource. So for businesses which requires hardware level security, they can use shielded VMs also. For that, you need a shielded image. Confidential VM is another type of VM which allows you to encrypt data in use. So you can use confidential VMs. Your data will be encrypted while it is being processed. It is easy to use with no changes to code or performance. I'm saying these are just additional offerings which are available. It says you can select confidential VM service when creating a new VM. So when you select this service, obviously, you will pay more to Google Cloud. Next is images, very important. Without an image, a virtual machine is incomplete, or you can't even provision a virtual machine. So when it comes to image, you need to understand a couple of concepts: bootloader, operating system, file system structure, software customization. Now, when it comes to image, Google provides you public images, which is Google own images, third-party vendor images, and community images also. So you can use premium images, like by default, Google provides you Linux images and its own Google Chrome OS image. However, if you need Windows images, it comes under premium image category, which means you will need to pay more to get Google to Microsoft image, Windows image. For Linux, it provides you CentOS, CoreOS, Debian, RHEL, SUSE, Ubuntu, OpenSUSE, and FreeBSD. And for Windows, it provides you servers starting from 2019, 2019, 2016, and 2012 R2. It doesn't provide you 2022. In some regions, it does provide. And it also provides you servers with SQL Server pre-installed on Windows. Then comes custom images. You can also create a new image from a VM. Let's say you want to deploy servers with your own external image that contains all the required hardening, all the required security solutions on it, like DLP, antivirus, VPN client, some native applications of Nextern. So what you will do, you will create a compute engine VM. You will deploy all the required softwares and applications on it, and then create an image from that VM. And later on, you can use that image to provision additional VMs. That's what image concept is. Custom image concept is. Next, machine images. Then we have machine images also, which is single disk backup, multiple disk backup, differential backup. So these are all the images which are available, and how does the backup works is what it is showing you. Disk options, very important. So at a bare minimum, when you provision a compute engine instance, you need a boot disk, a root drive, a boot disk that comes with a VM, which is persistent, which contains the operating system files. So it says it comes with a single root persistent disk. Every VM image is loaded onto the root disk during the first boot. So when you provision a VM and when it boots, the image that you have selected, which is OS image, Linux or Windows, it will be loaded on your root disk during the first boot, and then you can attach to a VM and boot from it. It's a bootable disk. It's a durable. It can survive VM terminate also, which means even if you delete the VM, the boot disk or the C drive will be survived. I'm saying will be retained. It will not be deleted with the VM. You can retain it and you can reuse it in future. Some OS images are customized for compute engine. You have customized images also available. You can VM, it can survive VM deletion if delete boot disk when instance is deleted is disabled. So there's a setting that you get while provisioning a VM, which is delete boot disk when instance is deleted. And this is by default enabled. You just need to uncheck that setting. Then your boot disk will not be deleted when you terminate or delete the VM. So that's the concept of boot disk. All right. Now, boot disk is also a persistent disk. Persistent basically means permanent, which is permanently attached to a VM or which is leased on the VM. That's what persistent basically means. So your disk that you attach to the VM, they are persistent disk. They are attached to a VM through the network interface. They are durable storage. They can also survive VM terminate. They can also be a bootable disk. You can attach to a VM and boot from it. You can create snapshots of those disks, which are incremental backups. Snapshot is basically similar to backup. In cloud, we use the terminology of snapshot, which is point in time backup. You can configure a snapshot policy to take a backup of the VM every day at 9 o'clock in the evening, post business hours. You can do that. And it will support incremental backup. So when you have a policy configured, backup policy configured, it will not take full backup of the VM every day at 9 o'clock. Incremental backup, which is the delta that changes from the previous day backup. That's what snapshots are. It's a point in time copy. Performance, you can scale your virtual machines or the disk with sizes. It comes in two options, HDD, magnetic, old days, SSD, faster solid state option, which is the current technology. You can do disk resizing, even running and attached. That you have seen that you can resize the disk when the VM is running and it is attached to the VM. However, you cannot shrink the disk. Resizing would always mean expanding the disk. If it is 100 GB, you can make it 101 GB or 1 terabyte, but you cannot make it 99 GB. Cloud doesn't support resizing because resizing has a potential to corrupt the data on the disk. So that is why cloud service providers do not allow you to shrink the disk. You can always expand it. It can be attached in read-only mode to multiple VMs. Zone or regional disk also comes. Encryption keys. Obviously, the disk is going to store data. Data means security. Security means encrypting it so that it is converted into a ciphertext. It does not remain in plain text and nobody can read it unless they have access to the encryption key. So Google supports Google managed, customer managed, and customer supplied. Now, Google managed basically means Google has its own encryption keys that it will use to encrypt the data. Customer managed basically means you can use Cloud KMS service to create an encryption key and use it to encrypt the data on the disk. Customer supplied basically means you will bring your own encryption keys from on-premises. You probably have a hardware security module. You will use that hardware security module to generate the encryption keys, or you can use a third-party encryption service to get the keys, and then you will upload them into Cloud KMS and use them for encrypting the disk. So these are the three options that Google supports. Any questions so far, guys? Okay, let's move on. Then comes local SSD. Now, this is something which is not available in other cloud. Local SSDs are physically attached to a VM. They are physically attached to the VM. They are not virtual disk. The persistent disk or the root disk is a virtual disk. But this is locally attached to the VM. It provides, now when you attach a disk locally to the VM, obviously you will get more performance. lower latency, and higher throughput than persistent disk. The size of the disk is 375 GB disk up to 24 and total of 9 terabyte per instance. Data survives a reset, but not a VM stop or terminate. So if you reset the VM, it is good, but but not a VM stops or terminate. So if the VM is stopping or terminating, you will lose the data. It is like a cache memory. You can use it as a cache memory on your server, which is fast, which has more processing capability. It is VM specific. It cannot be reattached to a different VM because it's locally attached to the VM. So you cannot just detach it and attach it to another VM. No. If you detach it, the data on the disk will get lost. You will lose it. Then you can probably attach a new SSD, local SSD on the other VM. But the same disk you cannot attach and reattach. That's about local SSD. In what scenarios we use it? We use it where we need higher performance, more IOPS. It's like a cache memory, very fast memory. Next is RAM disk. You also have RAM disk, which is faster than local disk, slower than memory. So you can also attach RAM disk, which is the same process. You can use when your application expects a file system structure or cannot directly. Okay. It's very volatile and it is on stop or start. It's like a cache disk once again. So you can see all the options. You can see a quick comparison of these disks. Let's just go through it and let me know if you have any questions. Great. So let's see when it comes to data redundancy, both persistent and HDD and SDD provides redundancy. Why they provide redundancy? Because Google creates multiple copies of your disk and stores them within the region so that if primary copy is lost, Google can get your data back. That's why they support redundancy. But since local disk is attached on the VM, RAM disk is also attached on the VM, it doesn't provide redundancy. Google doesn't create any copy of it. Encryption at rest, all the disks support except RAM disk because it's a cache file, it's a temporary memory, so it doesn't support encryption. Snapshot, persistent and SSD will support snapshot. Local disk doesn't support because again, it's a temporary arrangement. Bootable, your persistent and SSD will be bootable. Local disk and RAM disk, you cannot boot the system with them. Use cases, persistence, we can use it for general or bulk file storage. SSD we can use when we require random IOPS. So for boot disk, you can use SSD. For your data drives, where you can store some backup data which is hardly getting used, you can use persistent disk. So you can use a combination. And that's how the devices are configured these days. In fact, if you purchase laptops these days, you will find that they come with a combination of SSD and magnetic disk, HDD. So you will have, and since SSD is expensive, you will have a lower size of SSD like 256 GB or let's say 128 GB of SSD plus 1 terabyte of HDD. That's how laptops are coming these days to optimize the cost and to provide you more storage capacity. I'm saying 1 terabyte of SSD will be very expensive. So that's the reason they go with a combination. Same is the case here. You can use a combination on your virtual machine based on your workload type. Next, maximum persistence disk. You need to remember these numbers. When it comes to a shared core, give me a moment. Somebody from Nextern is calling. Yes, Aruna. Yep. So Aruna, right now I'm in the session. Would you mind if I call you at 7 o'clock when my session is over? Sure. After 7? I'm only delivering training for Nextern right now. Yeah, I'll call you after my session is over. Thank you. All right. So when it comes to the maximum limit, this is something that you need to know. And this only comes from theory. You know, on the portal, You will not find it written anywhere. So if you're using a shared core virtual machine, you can attach a maximum of 16 disks to that virtual machine. Now this limit is exclusive of root disk. It doesn't include root disk. So it is like 16 plus 1. And if you're using a standard high memory, high CPU virtual machines, the limit is 128. Now I'll tell you something. This is the highest limit. Azure and AWS doesn't support this many, these many disks. Azure supports a maximum of 16 to 32 disks, depending on the virtual machine time. And sometimes it goes for 64 also for very expensive virtual machine. AWS supports 64 at the max. Only Google supports this much of disk. Now the question is, do you think that I should really attach 128 disk on a server? Or I should attach more than 50, 60 disk on a server? I would rather say no. Why? Understand the HA concept. If you attach more disk, which means you're storing more data, what if that server goes down? You will lose access to data till the time that server comes back on. So you are increasing your single point of failure. That is where I do not have customers, or I do not recommend customers to attach more than 5, 6 disks on a server. That's it. Take a disk of higher size. Instead of attaching 100, 1 GB of disk, you can attach 1000 GB. You can attach one disk of 1 terabyte. That is also the right approach. So try and minimize the number of persistent disk on a server, because that will help you do the administration easily. Otherwise, you will have administrative overhead in the long run. It will create single point of failure. Okay. The persistent disk, this is the difference. Cloud persistent disk and computer hardware disk. Now, this is the benefit that in the cloud persistent disk, you get single file system, resize, you can grow. See, it clearly says in bracket grow. It doesn't say shrink. You can resize file system, best in snapshot service, automatic encryption. This is for cloud. This is for computer hardware, which is on premises. For example, it supports partitioning, repartition, reformat, redundant disk arrays, sub-volume, and encrypt files before write to disk. You will need to encrypt, but here it's automatic encryption. So you should always go with cloud persistent disk. Then common compute engine actions, which is so we will not be able to do hands-on lab today because I would need at least an hour or 2 hours to cover all the aspects of compute engine virtual machine provisioning, go through each and every configuration option which is there on the portal. So we will probably do that in our next session. Today we'll focus on completing the theoretical aspects. We are left with a couple of more slides. Let's complete them. Next is common compute engine actions. Now, what are my actions? As I explained the lifetime or the lifetime of a virtual machine, it is the same thing here. So your machine starts from boot, run, maintenance, and shutdown. This is the scripts. So at this point in time, at any point in time, you can execute scripts on the virtual machines. It is like remotely executing a script on a machine to take certain action or to accomplish certain task instead of RDP or SSH into the machine. Let's say I have a machine and I want to deploy web services on it. IaaS or Apache Tomcat HTTPD service. I don't need to log into the machine. I can directly do it from script. I can create a startup script and I can embed that script into the properties and it will run on the machine. It will deploy IaaS. So it's easy with cloud. As I said that you can move virtual machines, it supports live migration. This is the example of live migration. You can move virtual machine from one zone to another zone. And the command is gcloud compute instance move, and it will support live migration. Zone means you have a couple of data centers here. You have a couple of data centers here, but they are part of the same region. So machine can move to another data center. No problem. Then comes move an instance to a new zone. This is the option you can do. I will say if you want to do it automated, you can run this command. If you want to do it manually, then first take a snapshot of all the disk of the source VM for the backup perspective. Create a new persistent disk in destination zone restored from the snapshot. So let's say you want to move a VM. Now the VM has two disks, OS disk and data disk. Take a snapshot. The OS disk, you need to create an image. So you will create an image of the OS disk and then copy that image to the destination region. Wheresoever the destination region is, copy it, move it there, and then create a new VM in the destination zone and then attach the data disk that you have created from the snapshot. Assign the static IP to the new VM, update the references to the VM, any dependencies that you need to do, and then delete the snapshots that you have taken as part of your backup strategy or as part of your rollback strategy and original disk and original VM. So this is manual process, which will take a minimum of 30 to 45 minutes, maybe more than that. This will not even take 10 minutes. So you can use this command to do it. Snapshot. Now, as I said, what is a snapshot? Snapshot is a point in time copy of a VM of VM disk, not the VM. You're not backing up the VM, you're backing up the storage, root disk and data disk. And snapshot is stored into the cloud storage. The backend of the snapshot is cloud storage. However, that is hidden from the customer. You will not see which cloud storage bucket my snapshots are getting stored. No, hidden. Snapshot migrate data. So this is just showing you the process that you take a snapshot and then you migrate. That's it. That is all, guys. So we are done with the compute engine part. We are done with all the theoretical aspects of it. Let's do a quick quiz and let's see whether you are able to answer these questions. First, can somebody read this for me? Hemant?
Yeah.
Yeah, please read the question.
Yes. Which statement is true of virtual machine instances in compute engine?
Options?
Yeah. A VM in compute engine always maps to a single hardware computer in a rack. Compute engine uses VMware to create virtual machine instances. In compute engine, a VM is a networked service that simulates the future of a computer. All compute engine VMs are single tenancy and do not share CPU hardware.
Okay, so this is the question, and these are questions that comes into the exam. Now, if you feel that all the options are correct, then strike out whichever is non-relevant or which you feel is not there. Or so let's start with this. All compute engine VMs are single tenancy and do not share CPU hardware. Is that true?
Wrong. True. False.
No, right? It's false. Cloud is all about shared resources. Forget about it. Second option, B. Compute engine uses VMware. Did I tell you anywhere that it uses VMware technology?
No,
it uses KVM, kernel virtualization technology. So you're done. B and D are out. Your choice is between A and C. Now tell me, which one you find more appropriate?
C.
Absolutely.
A is also not correct. It's not maps to single hardware always. Yeah.
Absolutely. So C is the right answer. My compute engine is nothing but a network service. Why it's a network service? How do you connect to it? You connect it through an IP address. You need an IP address to connect to a system. So it's a network service that simulates, which looks similar to a computer. And that's it. That's what compute engine is. It's a virtual machine. It's a computer which is virtualized. So that's the right answer. Second. Madan, can you do me a favor?
Yeah. What are sustained use discounts? Right? Purchase commitments for a specific resource. You know you will use. Automatic discounts that you get specific compute engine resources for a significant portion of the billing month. Discounts you receive by using preemptible VM instances for a second billing that starts after 1 minute.
Yeah. So same process. Let's strike out which is not relevant. For example, D,
That
per second billing that starts from after a 1 minute. This statement is correct, but this is not for sustained use discount, right?
Yeah, that is
so
not
D is
default,
out.
right? So
Yeah,
that is not.
that's the default.
Not.
Second,
So
C,
it is again C. Discounts
See,
you receive
discounts
by
that you
using
receive by using
preemptible
preemptible VM instance. That is also
Yeah.
incorrect. Preemptible and spot, you get discounts, but that is temporary. Sustained is permanent. So C is also out. Then you're left with 1 and 2.
Automatic discount that you get for running specific computer engine resources for a significant portion of the billing month.
Absolutely, that's the answer. So based on how, based on for how many hours or how many days or throughout the month you've run that instance, you will get the discount. That's sustained use discount. And the other one, the option A is for committed use discount, where you are committing, you're purchasing commitments. You're telling Google Cloud that I will use 20 machines of this type and series for next 1 year. Then Google will give you certain discounts. This is on the fly discount. So this is sustained, and the other one, the option 1 is the committed use discount option. Next. Sundaresh, Dileshwar. Dileshwar, are you there?
Yes, Raghu.
Yeah, please read it.
Which statement is true of persistent disk? Persistent disks are encrypted by default. Persistent disks are physical hardware devices connected directly to VMs. Persistent disks are always HDDs. Magnetic disk. Once created a persistent disk can't be resized.
What do you think is the right answer?
I think it is A, because B and D is void, right? So
absolutely. See, B says it's a physical hardware device, and it's a virtual device. Physical hardware is local disk. So B is out. Look at D. It says it cannot be resized, which is incorrect. I just told you in the previous slides that you can resize it. You cannot shrink it, but you can resize it. So B and D is out. You're left with A and C.
Persistent disks are always HDD. That's what.
Which is also incorrect.
So it is
our persistent disk also support SSD, right? So you're left with A, which is the right answer, which is true. Persistent disks are always encrypted. Now, when I say always encrypted, either you use your customer managed keys to encrypt it, or Google will use their own keys to encrypt it. But by default, they will be encrypted. That's what the right answer. Next, that's it. So that is all for from theoretical perspectives for compute engine service. In our next session, we will focus on the hands-on for the compute engine service. We will do a lot of hands-on, and I'll talk about all the configuration options which are available when you provision a compute engine instance. All those options that we have discussed in the last 2 hours from the theoretical perspective will be validated and will be configured in the lab environment. That we will do in our next session.